Advanced Maths. Today we're going to be talking about differentiation from first principles. This is going to be a slightly longer video than normal, and it might get a little bit complicated in the middle. If it does, just rewind a minute or so and rewatch that section again, and so you're not too far behind. And that's absolutely fine. Differentiation from first principles means looking at the absolute basics of algebra and seeing if you can figure out how to differentiate from that. Okay, so let's look at a curve. I've got a curve over here, and I've got this red dot. And what I'm going to try to find is some sort of approximation for the tangent. The actual tangent is drawn here in this orange line. That's what a perfect tangent looks like. It's a line with the same gradient as the curve that just skims it perfectly. Now I drew that with a graphing calculator on, but if I wanted to do that with algebra, it's a little bit. I have to do it slower and with step by step. So the way I'm going to do this is instead of doing a perfect tangent, I'm just going to approximate it by finding a line between these 2 points here. I've drawn another point up here. And if I draw a line between them, I get this red line here. Okay? It's not a perfect tangent at all, but it's a kind of approximation for it. So let's find the gradient of that line. So we can put on some points here. And first we'll look at the dot down here, this point. And we'll say the x-coordinate of that is just x. And therefore the y-coordinate, because it lies on the blue curve, will be f of x. Then we look at the other point, the purple point up here, and we say we've just gone across a small number, h. H is just a number a letter we use in maths to represent a small number across. So the new x-coordinate is x plus h. So the y-coordinate must be f of x plus h. Just because we put the x-coordinate in, we will get the y-coordinate out of the function. Okay? So to find the gradient of this, we do the gradient is the change in y divided by the change in x. And a symbol we use for the gradient is dy over dx, which just means difference in y over difference in x. D stands for difference. So, what is the difference in y? Well, it's the difference between this y-coordinate and this y-coordinate. And to find that, we just subtract them. And it's f of x plus h minus f of x is the change in y. The change in x is even easier. We're just going across h. So from this coordinate, this x-coordinate, to this x-coordinate, we're going across h. So the change in x is h. And we have this equation here for an approximation of the gradient of the tangents. Okay? Now, how can we make this approximation even better? Well, look at this. We can move the 2 points closer together, and you'll see that the red line actually gets really close to the tangent. I can show you the tangent line now. There it is, it's the orange line. I'll move them apart again. Okay? And you'll see it gets further away, and if you move the points closer together, the red line and the orange line get closer and closer and closer together. So the closer together these points are, the better our gradient line is as an approximation for the tangent line. Okay? So we had this equation for the gradient of the red line. And we're going to see what happens when they get closer together. Now, for these 2 points to get closer together, the difference between the x-coordinates needs to get small. So the h needs to get small. And so we just say, what happens when h gets small? And we get this equation here, where all we've done is said lim as h goes to 0. That means what happens when h gets small. Okay? Don't worry too much about what lim as h goes to 0 is. It's all you have to know is it means what happens when h gets really small towards 0. Okay, and this equation here that we just found is the equation for the derivative from first principles. It's really important you remember this, so make note of this right now. You can pause the video and make a nice poster about this equation. Okay. The dy over dx just means difference in y divided by difference in x, and that's the symbol we use for the gradient function. The h refers to the small number that you increase x by. So you just add h to x to see what happens when you shift it up a bit, and the change in x will be h. And then the limit just means what happens when h goes to 0. Okay? Let's see this in action. So here I'm going to try and differentiate f of x equals x squared. And I'll use this equation here. Again. So I substitute x squared in as f of x. And I replace f of x plus h as x plus h squared. And f of x as x squared. Just notice that when whatever I've got in the f here just replaces the x in the function. Okay, and I get this. I then expand these brackets. X plus h squared becomes x squared plus 2xh plus h squared. Everything else has remained the same. And I can then simplify because we've got an x squared and a minus x squared. They cancel out, and we're given this. We divide through by the h's, because we've got some h's on top and h's on the bottom. And we get 2x plus h. We've still got a limit here. We always write down the limit all the way through. And now we take the limit. We see what happens as h goes to 0. Well, as h goes to 0, the h disappears. And all we're left with is 2x. And that is the final answer. Those steps there you will have to replicate in your exam, so make sure you understand those. We're going to see another example now for a slightly more complicated function. F of x equals 3x squared minus 5x. So we substitute x plus h and x in, and we're given this. We expand the brackets, and we're given this. It looks a bit complicated now, but it simplifies really easily because we can cross out the 3x squared, the minus 3x squared, minus 5x, and plus 5x. And then we divide through by the h, and we're given this. And then we take the limit as h goes to 0, and we're given 6x minus 5. Two things I want you to really focus on here is where I'm putting the x plus h. So the function is 3 something squared minus 5 times something, and whether the x was, I replaced it with x plus h in brackets, and that's what I expand. Also remember you're subtracting all of f of x on the end, so you're subtracting 3x, and you're also subtracting minus 5x. That makes it a double negative, that makes this a positive. So it's just a few things to be careful with there. And once we've got this, dy over dx equals 6x minus 5, we are finished, and we can write that as the final answer. Okay? What I would recommend you doing now is watching the previous two examples, but with the video on mute. So you're not listening, you're not focusing on my voice anymore, you're just focusing on the steps and seeing if you can follow the steps. Okay? And once you've done that, if you want to do some practice questions, all you have to do is try to differentiate f of x equals x squared, or f of x equals 3x squared minus 5x, and so you can do it without watching the video, and so you can remember those steps. If you're ready, you could try a completely different function. You could try differentiating 5x squared plus 10x, or any quadratic of your choice, to see if you get the right kind of answer. Okay? If you have any questions, please ask them in the comments. And thanks for watching this video with Advanced Maths. Please comment, share with your friends, and subscribe for more videos. Thank you, and have a good day.